Okay, 9.2, characteristics of quadratic functions. We're going to look at two things. We're going to look at the axis of symmetry and the vertex. And they actually share some information, so it'll be easy to do both of them together. First off, if you're given the graph of a parabola, then it's fairly easy to find the axis of symmetry and vertex just from the graph. The axis of symmetry runs down the middle of your parabola, and it's like those butterflies that you did when you were little with the paint, where you put paint on one side, folded it, opened it back up, and it was identical on each side. A parabola shares those same characteristics. The points on one side of the axis of symmetry match the points on the other side. Okay, so from a graph, sometimes you can just tell because your axis or vertex is easy to find. If not, we're going to average the two zeros. Remember back from linear functions, we talked about zeros of a function was where that line crossed the x-axis. Same thing with a parabola. Only with a parabola, sometimes you can have two zeros, sometimes you can have one zero, sometimes you may not have a zero at all. And we'll talk a little bit more about that later. So first of all, if I look at this first example, I've got a 0 here at 5 and a 0 here at -3. So I'm going to add those 2 points together and divide by 2, just how you find an average. And I find that my axis of symmetry lies at 1. There's the dotted line right there at 1. Okay? The nice thing about finding the axis of symmetry is if you find it and then you have to graph it from an equation, let's say, you can just graph points on one side of it and just mirror it to the other side. Okay, so now what if your parabola doesn't cross the x-axis? That would be if it opens up and lies above your x-axis, as here, or what if it opens down and lies below the x-axis? It still wouldn't have any zeros. Okay, so in this case, you're going to have to identify the vertex. The vertex, remember, is either your maximum or your minimum point of your curve on your parabola. So in this case, it's going to be the minimum, and then you just have to do your best to estimate whole numbers. And I think that this book is pretty nice about only giving you whole numbers for a vertex. And I really only care about the x portion of the vertex. So if I come down here, it looks as though the x portion of that vertex is at -6, so my axis of symmetry is the line x equals -6. So let's do two examples of these. Okay, number 1. I happen to have zeros. Okay, the first 0 is at -2. The second 0 is at 8. Let's average those. -2 plus 8 is 6. Divided by 2 is 3 for axis of symmetry. Okay, another example. Earlier I mentioned you can have 2 zeros, 1 0, or no zeros. This is an example of having 1 0 when your vertex actually lies on your x-axis. So there's my vertex lying on my x-axis. I'm just going to take the x portion of that, which is 2. I could go ahead and even draw that axis of symmetry in. It will always be a dotted line. Okay. Well, what if I'm given an equation? Now, this example goes ahead and gives the graph, which is kind of nice, but what if I just have the equation? Guess what? There's a formula for that. There always seems to be a formula in Algebra 1. So here's my quadratic function. Identify a, b, and c just like we did for 9.1. So a is a half, b is 4, c is -2. Okay, here is my formula. It's the opposite of b divided by 2a. So that means if b divided by 2a is negative, the opposite of a negative would then be a positive. So it's just the opposite of whatever these numbers turn out to be. So here it's the opposite of b was 4, 2 times a value of 1/2. So it's the opposite of 4 divided by 1, so -4. So my axis of symmetry is -4. Now they went ahead and graphed it over here. You don't have to graph it unless the book specifies. But now it says find the vertex. Well, to find the vertex, because they share points, I just simply plug in -4 in for my x values from my equation. So I go through, simplify, y is equal to -10. So my vertex is going to be the axis of symmetry, x value of -4, the y value that I just solved for, -10. Let's go ahead and do two of these examples. Okay, first of all, let's identify a, b, and c. So I'm just going to write that up here. A is 1. Remember, it's that arbitrary value. B is 4, C is 4. I don't really need C for this portion, but we go ahead and label it. So first let's find my axis of symmetry. The opposite of B is 4 over 2 times A is 1. So the opposite of 4 divided by 2 is -2. There's my axis of symmetry. My vertex, all I do is take this value of -2, plug it in for my x's in my quadratic equation. So 1 times -2 squared plus 4 times -2 plus 4. So I've got 4 plus 4, I'm going to start over right there, guys. I have a negative and a positive, sorry. -2 times 4 is -8, so it's 4 minus 8 plus 4. 4 plus 4 is 8, minus 8 is 0. Therefore my vertex, the x value of -2 for my axis of symmetry, the y value that I just solved for, my vertex. Okay, next example. Let's go through and label. A is 2, B is 4, C is 1. Okay? Axis symmetry. Opposite of B is 4 divided by 2 times A is 2. Opposite of 4 over 4 is -1. Axis of symmetry. Vertex, remember I just take this value and plug it into my quadratic formula. Quadratic equation, sorry. So 2 times -1 squared plus 4 times -1 plus 1. -1 squared is 1 times 2 is 2. I have a negative. Negative times a positive is a negative, so I'm just going to go ahead and make that sign there. 4 times 1 is 4 plus 1. I always do my addition first, so 2 plus 1 is 3, and then I go back and subtract -4 is -1. So my vertex lies at x value of -1 for my axis of symmetry, y value of -1 that I just solved for, and there's my vertex. All right, that's it for today.